Welcome back, everybody. All right, we are right on time. So I want everybody to start making your way to your tables. Get your coffee in hand. You want to be highly caffeinated for this, almost as caffeinated as our speaker is about to be here. And if you aren't already caffeinated, you will be jazzed after you hear what Dr. Matthew Szydagis has to say. So we'll get right into our introduction. Dr. Matthew Szydagis received his BA, MS, and Ph.D. degrees from the University of Chicago, then worked as a postdoctoral scholar at the University of California, Davis. He is now an associate professor at the University at Albany, SUNY, studying experimental particle astrophysics, in particular, direct detection of dark matter, as well as general detector development of rare event searches. He was inspired by Star Trek: The Next Generation as a child to become a scientist, and has always been fascinated by the UAP phenomenon, treating it seriously his entire life. He's a contributing member here to the SCU, and he's about to blow your mind, as he does every year. Please make welcome Mr. Dr. Matthew Szydagis.
Thank you. All right, thank you, Micah, for that wonderful introduction. And thank you, everyone, for being here. Thanks to Rich and the organizers for inviting me to speak again. I actually have like 2 hours worth of material, 3 different topics. So it's going to be a real challenge to crush it into 30 minutes. So I strongly encourage everybody to just rewatch my talk on Hoover and pause and look at, especially to grab the links, because remember, as Mike has emphasized, photography, not permitted, videography. I'm gonna be going too fast for you to be able to get the links that I have in my slides, but you can just go on the Hoover app and you can just rewatch my talk and grab things. So before I launch into my main topic, which is how much time do we have before catastrophic disclosure occurs, I want to first share some amazing news that Kevin already did yesterday, though. But this really cannot be, we really can't overstate the fact that Kevin and I have both published papers that are on this topic of UAP in the highest impact factor journal to ever carry this topic. Progress in Aerospace Sciences. This is a monumental achievement. It's not my achievement or Kevin's, it was a team effort in both cases. So there's Kevin's summary paper, but there's also the UAPX paper where we talk about our expedition and what potential anomalies we found. I'm not talking about that today because I've spoken on that twice already, but there's so much in there to unpack that the only thing I'll mention from the UAPX paper on this slide is the fact that we suggested how to quantify the meaning of extraordinary evidence. And that's just one of many things we did. Strongly encourage people to read these papers and to go to the SCU YouTube channel to see my talks from previous years. The one thing I'll mention is I do have a little bit berating of the audience for people who are familiar with the UAPX paper. I know for a fact that I can count on the fingers of one hand people who have actually read it. And the reason I know this is because we put bombshell details in there that if people had noticed, I would be getting emails about them. And one of them is, so in the famous anomaly, if you're not familiar with the UAPX, which is an organization I belong to, also belong to SCU, and we did an expedition to Laguna Beach and Catalina Island. We caught at least one potential anomaly. It has some maybe prosaic explanations, which was a dark spot in one of the cameras with these little white speckles. And in figure 7, of caption of the UAPX paper, it's just casually mentioned, nobody noticed, that that if the white dots are at the altitude we think they are, that they're consistent with Tic Tacs in size. We also have Doppler radar data that suggests that. Again, nobody noticed that because otherwise I think people would have lost their minds. And so I strongly encourage people to read this. We have all kinds of other Easter eggs like that in the UAPX paper where we discuss frankly what works and what doesn't work. We have appendices that talk about trigonometry and how to disambiguate size and distance for UAP sightings. There's tons of stuff in there, but I've already spoken on this twice, so I'm not speaking about this paper today. I just had to mention the fact that it's made through peer review, which was really a huge achievement. And so I'm going to focus on my main topic, which is the scenario where the military-industrial complex is not the player driving disclosure. And so with apologies to Nick Gold and others, is my opinion, it's an opinion, is that nothing's ever going to come out of the government. If they know stuff, we are not going to find that out. We can try, and I respect people in the disclosure movement. I'm just skeptical that it'll ever be successful. And so I'm focused more on grassroots of scientists, engineers, and citizens citizen scientists. And specifically in the publication, in the paper I'm going to be talking about today, it's not Kevin's summary paper or the UAPX paper. It's a paper that I wrote by myself talking about the potential for capturing of an actual crash of a physical craft using smartphone imagery, for example. So that is my particular scenario I'm talking about initially today. So as far as I know, this is the first. I know Ben Hansen has been using similar ideas, but I don't know if he used the same phrase. But the first time I've heard this phrase used was at the Soul Foundation's first a conference, this phrase catastrophic disclosure. So but I'm talking about a specific version of it because there are numerous conflicting definitions, but I'm talking about the idea where you literally have a physical craft that has crashed. You have, I don't know, like half-dead grays crawling out of a crashed saucer, and someone's captured it on their iPhone. That's specifically what I'm talking about today, and using our tools of mathematics and statistics to determine how likely such a scenario is. So here are my foundational assumptions: that some kind of NHI exists, or some sort of human analog of that, an advanced yet unknown group of humans, some sort of breakaway civilization. So even though the first bullet says NHI, I already have an exception there, or some group of advanced technology. And whoever they are, they possess high-tech craft operating on or near the Earth's surface. The point of origin and motivations are not relevant to the study I conducted. The other assumption is that they possess some degree of fallibility, means that unplanned, aka crash landings, are possible. And so I made several quantitative assumptions. So these are for the scientists, engineers, and mathematicians listening. So this is the math, but it's better to understand the math with pictures. And so I have here in this figure all the different quantitative assumptions that went into my study on crash rates and crash retrieval possibilities. So first of all, in figure A, what we have here is a histogram of the distribution of the population density. So humans, in case you didn't notice, I've met people here from different states and across the world. There are people here at this conference, where they could drive for hours and not see another human soul. So the thing is that human population is not uniformly distributed. We take that into account. And so if there are random crashes of UAP or NHI craft, if that is a real phenomenon, then we need to take into account the distribution of people in the world. We also need to take into account, and this is in figure B, is what is population growth as a function of time? We don't know. So I'm using UN projections for explosive population growth or flat, there's a middle curve, and then also the lower one. And then in C and D, where D is an inset projection into the future, we look at the smartphone ownership fraction. Okay, so we all have, these little, we have all these devices in our pockets that have the capability of potentially capturing something truly extraordinary. And that was not true during, in Roswell, Kecksburg, Pennsylvania. They didn't have iPhones yet, or Androids or Samsung. We have this capability now. And so another assumption was looking at the different possible distances involved. Now, all of these, the purpose of all of these assumptions are to be seminal and foundational. I'm not claiming any of these are correct. What I'm doing here is what's known as a Fermi estimate, just to get orders of magnitude. So you can nitpick all of the assumptions made in my study, and you should. But the point here was not to make a perfect study and perfect conclusions, but to encourage more people to actually apply math and statistics and not just qualitative assumptions to this problem. So the results of the simulations, I needed one more assumption, which I call here in the upper right. There are 3 different levels that again are just very crude estimates, and they're not meant to be precise or accurate. So one is what I call the Roswell crash rate. We say it's like something like once a century. And then we have what I've labeled the David Grush curves, are estimating 10 crashes per century on land. And then the curves labeled Kevin Randall are 100 per century. So Kevin Randall wrote a book where he had lots of different crashes. I have an asterisk by his name though, because he actually thinks it's closer to 1 to 10 per century. So I want to make sure that if Kevin's out there, I'm not claiming. He says in his book most of those are hoaxes and misidentifications. So I'm just labeling that because it's based on his book, not because he thinks there are that many. And so when we look at these different scenarios, we have on the left in A and C, this is the percent chance of someone capturing a crash on their smartphone and posting it to the web as a function of the year and of these different scenarios. Roswell, Grush rate, and the extreme rate of there's 1 per year. And we can already start to rule out, you can see here 1 per year, because you can see that there's a huge peak that we should have had. There's a huge peak to the left in A and C where we should have had, someone should have already captured something. And on the right-hand side in B and D, what we find is that if there's a finite probability per day, the probability asymptotes to 100% eventually. So it has to happen eventually. Now people say, well, will smartphones even exist in the year 2300? No, we'll have something better, which makes these projections conservative. It does not invalidate the conclusions. It actually makes them stronger because we might have something better than that in the future. So if there's a very low crash rate, we might be waiting for a while. But if we take the median assumptions like the Grush rate and a median assumption for human population growth and smartphone ownership, we get asymptotes pretty rapidly to that it's going to happen eventually. So again, with the assumption that NHI are real and fly craft around that are capable of crashing. So there are many arguments and counter arguments on the assumptions I've made, but most of those arguments make this just strengthen the conclusion. So some people point out, well, wouldn't NHI technology improve over time and they'd crash less? And I always like to point out that it's actually a myth that technology improves exponentially. If you don't believe me, compare your laptop now to one 10 years ago. It's the same, because Moore's law died. Here's an even better example. If technology improved exponentially, you'd be able to fly home in a minute instead of several hours. Like, why does it take 8 hours to cross the Atlantic? The problem is actually no technology doesn't improve exponentially, eventually maxes out. And if that's true for humans, why wouldn't that be true for non-humans as well? So I push back on all the counter arguments on my on the assumptions I've made in my study. You can dig deeper into them. You can see what's the mean year of disclosure, by which I mean, again, driven by somebody finding like really damning, evidence on a phone with video, multiple angles, and as a function of time. And you can see as the crash rate goes to 100, 200 per century, it's just not tenable because somebody would have caught something already on their iPhone or Android. So we can actually reverse engineer the math here to the more years that go by without something happening, being posted to YouTube or TikTok, that reduces, that allows us to put a bound on the rate of crashes. And you can use the same mathematics I present in my paper entitled How Long Until Catastrophic Disclosure Occurs. You can use those same techniques for orbs, for Bigfoot. You could use it to determine what's the Bigfoot population per square mile. That's what's so powerful here is the math is neutral. It can be used for debunking or for proving. Math is math. It's neutral. And so you can use the same framework that I use with simple assumptions, change the assumptions, and look at what the results are. So when we extract what are the main takeaways from all these plots, the main takeaways are that if NHI are real, then the correct question asked is not, and if they can crash, then the correct question asked is not if disclosure can be forced, but when. The figures I have show the probability always asymptotes to 100% eventually, which makes sense because if there's a small chance per day, right, eventually, then that means it's gonna happen. So when we input the default curve, so what I mean is like, an average assumption on population growth, smartphone ownership fraction, things like that, and using the like middle of the road projections, then I get between a 14 to 42% chance that someone captures evidence of a real anomalous physical crash by the year 2027, and a 39 to 59% chance by the year 2036. And why are there two numbers? Why are there ranges there? Because it depends what year do I use. Because do I use the year 2008, which was arbitrary, it was the introduction of the Apple iPhone, but there are plenty of other competing camera phones in different years, and so that was just one assumption. Another was starting in the year 2024, since that's when I wrote the paper and disclosure hadn't happened yet. And when you do that, when you input 2024, that's when you get these huge peaks that suggest that disclosure is imminent any day if the crash rate is the more optimistic number that it's one per year. So I had gotten into, little fights over email with Mick West about how this is a waste of time, garbage in, garbage out. And I think garbage in, garbage out is one of those tired old phrases, kind of like extraordinary claims require extraordinary evidence, because even if my assumptions are wrong, that doesn't mean my algorithm is invalid. I think that's false. Now, there are many issues, though, that AI, of course, will muddy the waters. But for now, at least until AI gets better, you can just count the number of fingers, or just look for letters. So my recommendation my serious recommendation to people is that if you're filming an alleged, NHI crash, wiggle your fingers from the camera and point it at a stop sign or a speed limit sign, which will prove it's not AI. Now, I know AI is always improving, so this is just a temporary fix. But right now, AI is absolutely terrible at making high-quality, accurate images of humans, and when it comes to fingers, things like that. So if you've seen the new Mission Impossible movie, we're still a far cry from the Entity or the Skynet from Terminator. But we can use this to our advantage, because just like with Photoshop and other tools, there are digital forensics, is what I'm trying to say on the sides. There are digital forensics. All jokes aside, there's digital forensic tools that allow us to help determine whether videos are fake or not. There was discussion of this already this morning from Sean. We can capitalize on these. Future work, ideally not by me, because I'm moving on to other things that I'm going to be talking about the rest of my talk, but I strongly encourage somebody else to take my study, cite it, and write more about it. I have code that I wrote that is public. It's downloadable. I doubt a single person has downloaded or tried it yet, but I have a short piece of C++ code that runs the algorithm to make the graphs in this study. So it's downloadable either from the archive version or from the Limina. So I forgot to mention, so my paper is published in what I believe is the only externally peer-reviewed journal that's run Limina. It's run by the Society of UAP Studies, and there also it's downloadable in the supplementary material. So you can download my code that I wrote and change the assumptions and see how that changes the conclusions. So there are many potential things. I modeled the crash rate as Poissonian. What about log normal? What about some other statistical distribution? You can change that. What if NHI behavior changes over time? I mentioned, what about technology changing over time? What about information management by whoever's pulling the strings? What if there's some sort of call down ability that makes it easier to do? What if the appearance of craft is non-random? We heard from, there's the SU intention study that shows that you could have more UAP at military sites, particularly nuclear ones. What about psychology? You have ontological shock and you don't pull out your phone in time. These are all factors that I didn't consider, but I recognize, and that was another way I could tell when people started emailing me, you didn't consider this or that. I can say, oh, so you didn't read the paper. Because on the last page, I humbly say, and these are the things that I didn't have time to look into. And so I just say, these are the drawbacks of the study. It's literally on the last page where I say, I hope that future scientists will actually read the paper, take it seriously, and write either a furthering study or a rebuttal, whatever. There's one thing that I deeply regret that I didn't have time to do and I won't have time to do, is to validate the model using something we've already seen on smartphone cameras or security cameras, things like earthquake lights and ball lightning, where there are at least 4 or 5 videos that I know of that have not been debunked. So there's this there's this Chinese video. Again, there's a link here. You're not going to have time to write it down now, but pull it up later on Whova, where there's a video And there are a few of these that claim to show ball lightning. There are many, many for earthquake lights. And in fact, I'm on a TV show called The Proof Is Out There. Rich is on it as well. And I'm always watching, Bigfoot and UFO videos. And I've seen more and more earthquake lights where it's like pretty damning evidence. There's a flash of light, there's no thunderstorm, and the earth starts shaking, and you got like from two different angles stuff. So these are things people used to laugh at. They used to laugh at Friedman Freund, who was the pioneer in earthquake lights. And so these are great examples of controlled data sets that I didn't have time to look at that could be used to validate the model. You can see here, this XKCD comic is one of the inspirations I had for my study. Was XKCD has claimed that UFOs have already been ruled out because of smartphone ownership. And what I showed is actually no, depending on frequency, it's entirely plausible that it's going to take another 10, 20 years or even longer to get evidence. The same thing with Bigfoot. If the population is not very, is very sparse, then, there are very reasonable reasons. And it's the same thing with ball lightning and earthquake lights. It didn't happen overnight. It wasn't like the day after the invention of the camera phone that all of a sudden everything was resolved. That's not what happened. So if a PhD scientist takes my paper, reads it, writes their own citing it, I think that will then demonstrate to me that UAP studies will finally have matured into a real science, where people aren't working in a vacuum, but they're actually citing each other and continuing the study. So I've literally given 5, 6 different ideas out there for people to continue the study. So I hope that somebody does so. Because what I want to focus on for the remaining time I have, and especially because I really don't want us to have to go to, oh, we're out of time and there's no time for questions. I really don't want that to happen. But I have another really major topic that I snuck in that is not in my abstract for the conference. But the conference theme is the foundations of UAP studies. So what is an even better, I would say, foundation than pictures and videos, although we need those, is to study physical evidence. So I have been working with Mark Sokol of Falcon Space. He's right here. Jared Yates of Flux, and Tim Ventura of APEC. And I received, and as for show and tell, I actually have right here, it's inside, it's a very tiny piece of material, but an alleged crash piece from 1947 New Mexico. This is the famous art part that's primarily magnesium, zinc, and bismuth, and many, many other trace elements. And I'm doing elemental first analysis and then isotopic, and the latter is better for checking if something is extraterrestrial or not. So one thing that science fiction always gets wrong is that it's the same elements throughout the entire universe. 100 billion light years away, it's still hydrogen, helium, lithium, it's still the same periodic table of the elements, but what changes are the slight differences in the number of neutrons in the nuclei. You get slightly different isotopes. And so I've been actually switching my focus, because I think we shouldn't. I have this little cartoon here. We need to make sure we're looking at all the right places, and that includes studying not just photos and videos, but physical trace evidence, which has a long history, very long history. Also UAP studies and lots of papers on physical evidence from alleged landings. There's Delphos and Socorro and all this. So this isn't new, right? I'm just following in a long history of physical evidence analysis. But this is what really excites me, is that there's physical evidence I could get my hands on to test what it's made of. So one of the tests we did was an X-ray fluorescence analysis that I was doing with my student, PhD student, Andrew, and we found a whole bunch of, elements in the sample. But what was really remarkable is few interesting things. So first, we found a very strong signal from argon, which seems to suggest that the sample's terrestrial, because argon is used in magnesium and zinc mining on Earth, and those are the two most common elements. But so that may seem like, oh, it's not very interesting, but no, I assure you that it's not a cut and dry case. It's not an open and shut case like that. So, but what's really, really strange is that in 20 seconds, we were able to do a more thorough job than the official Oak Ridge National Report with arrows. So there's something very, very wrong there, something very suspicious, is how were we able to move so quickly and start identifying things that were missing in the official PDF report. So we don't know what's going on there. It could be, Arrow didn't have the funding, that it needed, or, I mean, we were already beating up on him earlier. It could be Kirkpatrick's fault. I'm not, laying any blame on the current regime of Arrow, current leadership, who I know here. Like, I don't know what the story is, but we were able to do a much more comprehensive job, and in fact, to see elements that was not found that are not labeled in the Arrow report. And one of them is, I put a red box here on the lower left, we actually found traces of uranium in the sample, in addition to all the other elements that were known from the other reports. So a colleague, Professor Cecilia Levy, who is one of the co-authors in the UAPX paper, she's our personal Dana Scully. And so she suggests, think I know what it is. It's a nuclear bomb casing. But as Mark Sokol points out, that doesn't fit all the facts, because then how is there a piece at all? Why isn't it all vaporized? So again, we have conflicting pieces of evidence. It's anomalous, it's prosaic, it's terrestrial. But what it definitely is then, it's interesting. And one thing we were able to determine for sure, one at least function of the material. And no, we did not demonstrate warp space-time. No, we didn't demonstrate it's a magical terahertz waveguide. No, but we were able to demonstrate conclusively, quantitatively, is that this material appears to be a neutron absorber or reflector. So it works very well as a radiation shielding. That does not prove it's terrestrial or extraterrestrial, because that could mean, it's terrestrial. It's a nuclear bomb or reactor casing or shielding. Or it's extraterrestrial, because guess what you need for interstellar travel? Shielding, right, against radiation as you're traveling the interstellar medium. So that does not definitively say it's prosaic versus it's extraterrestrial. So the most exciting analysis we have started doing is something called neutron activation analysis, or NAA, although I know Kevin has said he hates all the acronyms. We make so many acronyms up. So what's remarkable to me is I've had, Kevin has told NASA scientists about this who are like, what is that? I've never heard of it. And that shocks me, because NAA is not something I invented at UAlbany. It's a decades-old technique that somehow the entire scientific community has developed collective amnesia for, and I cannot explain that. NAA is a beautiful technique that allows you to determine what isotopes are in a material, not elements, isotopes. That's better than just determining the elements, because it's a way of determining whether something is terrestrial or not. But unlike mass spec, which was done by Arrow, this is non-destructive. You don't have to vaporize your sample or laser ablate the surface, which, by the way, how do you know the surface is indicative of the bulk, right? So this is vastly superior to existing techniques, and as far as I know, it's only been used once or twice. I think it was used on one of the magnesium Ubatuba samples or Palatomi, but this has not been used consistently, despite how simply it can be applied. So the basic principle is that any atom, any isotope, any nucleus is happy to accept one extra neutron among its protons and neutrons, and it becomes temporarily radioactive. And that's so safely, like it decays away usually most things very quickly with that one extra neutron. But while they're decaying, you can count the alphas, the betas, the gammas, look at their energies, look at their half-lives, in order to uniquely determine whether something is made of. And to lead into this study, so this is still connected with the first half of my talk, because you see here on slide 16 that I quote my crash paper, and I actually, in order to lead into this study, I literally say that a smoking gun phone video might not be enough. Right? It doesn't matter if it's two or more witnesses from multiple angles. We've got plenty of photos and videos, right? And there's still a gigantic debunker community, right? But physical evidence is something that could trump even the best photo or video evidence. You cannot. It's not impossible, but it would be like a billionaire hoax, like in the movie Contact. Like you would need $1 billion hoax if you have completely different isotopic ratios and strange different material properties. So the preliminary findings they have, and preliminary is the key word. It's not peer reviewed yet. We are not done. And I even have, disagreements, respectful disagreements with Mark and Jared on the preliminary findings. So it seems to be earthly but odd. So one thing that's very strange is that it was very hard to do neutron activation analysis. So the art part which is, if you're familiar with that, that's the part that I'm testing. It's traced to Art Bell of Coast to Coast. There is a chain of custody, I believe, that Jared can talk about that we can trace. And Linda Moulton Howell, and also Hal Puthoff had a piece of the mother piece, or as the mother piece himself at TTSA. One thing that I discovered at UAlbany that somehow for decades nobody seems to have noticed is that it's very resistant to neutron activation, which is not normal. So because it was resistant to neutron activation using californium, we left the part next to plutonium. I actually have a large quantity of plutonium at UAlbany from the US Department of Energy for research purposes. We left it next to plutonium for a month, took it off, nothing happened. It wasn't radioactive. Now, that's not normal. So that suggests it's either reflecting or absorbing neutrons at a very, very high level, because it should have been neutron activated. So unlike alphas, betas, and gammas, which are not contagious, if you don't inhale them on a piece of dust, for example, they're less likely to hurt you. Gammas can travel a great distance, but still, neutrons are unique when it comes to radiation because they're the only form of radiation that's contagious on a subatomic level. If you hold a neutron source, you will be activating the carbon, the hydrogen, oxygen in your body. So it's very strange that this material appears to be resistant to neutron activation. As a result, that's going to make the isotopic analysis very hard. So actually, I'm very grateful, even though I beat up on them, the Oak Ridge and the Arrow report are very, very important to use to compare to our results and contrast with them. So the prosaic explanation, again, is some kind of well-crafted atomic bomb shielding, and the speculative is an interstellar spacecraft ablative hull. Both hypotheses have very serious drawbacks. Very serious drawbacks. It's not cut and dry for either to be able to conclude either of them. But what's shocking to me, again, is that Oak Ridge National Laboratory is the world leader in neutron activation analysis. So why didn't they think of doing it with this part? So something strange is going on here. It could be something as simple as lack of funding or interest. It's not necessarily something malevolent or malicious on the part of the government. I can't conclude that robustly, but it's very odd that the world leader in NAA didn't think of doing this type of analysis. Or maybe they did and it wasn't working very well. So this is an idea from Jared, is that this is sort of like a mithril for radiation. So I'm a large Lord of the Rings fan, so I thought I would throw that in there. Near future work with students. So over the next few months, we're going to be looking at the biggest signals we get and attempt to extract at least 2 or 3 peaks per element to compare to earthly isotopic ratios. So right now, we only know what elements are in there, because in order to do isotopic ratios, you need at least 2 different isotopes of the same element. So even though the plutonium didn't work, shockingly, we were able to get a little bit of a signal from a californium source activation. And consistently, the top elements are no surprise. Bismuth is top element. That's not a shock. We know it's in there. Argon was a shock, and we double-checked that. It's both in the XRF and in the NAA, and that was one of the damning pieces of evidence that suggests it's terrestrial, even though it's unusual. We see plenty of Na and Cl, so it's like, okay, people didn't handle it, properly for years with gloves, and so there's evidence of salt on there, and carbon, which we're all carbon-based life forms, so it's been touched over decades. So the top 6 elements have been pretty consistent, but now what we want to do is try to find individual peaks from individual elements. So I also should emphasize there is no magic technique. So NAA is complementary to earlier work. So for example, magnesium barely shows and zinc not at all, when that's what most of the material is made of. Because the purpose of NAA is not to tell you what the bulk of the material is made of, but what are the parts per million and parts per billion dopants and small trace elements. Some of those trace elements, I have to emphasize, are accidental. They're not going to serve a purpose. If you just grab a hunk of aluminum or copper, you're going to get a whole bunch of things. But so it's always hard to tell what's just a random trace element from manufacturing versus what's intentional. So One of the other studies we've done with the part is to use different types of radiation detectors. So while the Star Trek tricorder doesn't exist, we do have, there's the Cosmic Watch that Wes mentioned. There's also the radio code nuclear spectrometer, which I've been telling this, to Doug and Ben and others, is we got to stop using, 1970 called and wants their Geiger counter back. The Geiger counters are not used by serious scientists anymore. We now have far superior technology, and one of them is the radio code nuclear spectrometer that only costs $275, and it runs circles around Geiger counters because it doesn't just tell you the count rate, it also tells you the particle type and the energy. Well, not so much the particle type, but it gives you peaks for the energies, and this is what we're going to use to help disambiguate the different half-lives that overlap so closely that it's hard to tell what the different isotopes are. So calibrations take time. So I think John Oliver said this on the show, that science moves slowly, it moves boringly. So we're not going to, today's findings I share with you are preliminary. They're subject to change. We're not going to have a peer-reviewed publication on this until at earliest the end of this year and more likely next year, because it's going to take time to double check and triple check everything I'm claiming here today. So in conclusion, because I see 5 minutes left, which is great, I really want to have questions, not just on Whova, but hopefully here in person, is that, okay, so if you have real ET samples, send them to me. But I got to point out the vast majority of people who have sent me samples, they're meteors, they're airplanes, and please don't send me Bigfoot scat. Send that to Jeff Muldrum. But also, I'll already tell you what it's made of. C, H, and O, because that's what everything is made of: carbon, hydrogen, oxygen. If it's organic, that's what's in there. So I already know the answer. I'm not paid to do this for much longer. Hopefully things are changing right now for me. It seems where I might be able to I might have some funding to be able to continue this, and for that I'm grateful. I'm thankful to Jared Yates, who's here. I don't know where he's sitting right now, and the lights are so bright that I can't see him, is that I'm working with Flux Space now on this, and I'm really grateful to them that I'm able to be able to actually spend time, money, and effort on this now. And lastly, a shameless plug for my exotic propulsion class, which again, you're not going to have time to write down the link, but I hope you can go back on Whova, go to my last slide, slide 21, where you can see where you can register for my class, where I'm teaching this online for the second time now, and Maya Cowan, who I believe is here, she has posted about the class in Whova also. So if you want to hear about exotic propulsion technologies from a Ph.D. physicist, I hope you will take my class. So with that, I'll be happy to conclude and answer any questions that people have. Thank you. Yeah.
Matthew Szydagis, boy, did I tell you? He's going to blow your mind. Let me just also say, as we've got some folks coming over to make, to incorporate some questions into this Q&A, I love seeing scientists who have your energy and your enthusiasm. And again, anybody out there who's interested in seeing the continuation of work like this, please consider reaching out, collaborating, sending samples, funding, all these things. That is so very necessary for the continuation of scientific studies of these great mysteries, all these questions, and again, the technical aspects of all this. So, Stephen, let's go ahead and just start with a question right here from in-house. Go ahead.
Thank you. Very interesting talk. I like it. With the NAA analysis, you said that the plutonium didn't elicit any. Mm-hmm. Basically, you couldn't do the testing, but I thought I saw in there that californium or something did seem to be absorbed radiation a little bit. What was the result with the isotopes in there? Were they unusual in any way as it decayed?
No, I was talking a little fast, so you probably missed this because I was trying to finish. I didn't get to the isotopic analysis yet. I only counted different elements. And the reason is because the data is such shockingly poor quality, low statistics, because the sample is so resistant to neutron activation. So with plutonium, it didn't work at all. With californium, it works a little bit. That in and of itself is not entirely mysterious because different radioactive elements, californium and plutonium, will have different neutron energy spectrums. So depending on the elements, isotopes in the sample, they'll have different absorption capability, or probability. And so we do have data from the Californium, and we know for sure what elements are in there, and they're confirmed by either the error report or the X-ray analysis. So there's no surprise on the elements except the uranium, but then the isotopic analysis, that is moving slowly because that we have to identify a minimum of 2 peaks per element. But if you look at the error report, they did some isotopic analysis again, and they claim it's terrestrial, which would jive with what we're seeing in terms of, argon is a tracer that says this was probably manufactured on Earth, but we didn't have the technology. If you look at Jared's work with microscopy, that doesn't jive with the strange structures you see microscopically that seem to be beyond human technology, at least in the 1940s. So it's not a cut and dry case, and we want to do more. We want to dig into isotopic ratios and dig deeper.
Excellent. Here's an interesting question also from our HUVA participants. If you are looking for a craft with case-shielding neutron reflectors and uranium, have you considered the nuclear thermal rocket program run by Los Alamos?
Yes, that's a very, very plausible explanation, but as I said a moment ago, not perfect. And the reason why it's not a perfect explanation is because this is a very interesting combination of elements that I don't think we would have thought of in the 1940s. And so if you look at the microscopic structure of the material, it does not appear to have been within human capabilities to bond these elements together in this way. So on the surface, that's a very, very good explanation, and that's definitely the one we're going to use to get it published, right? It's not going to say, oh, it's a UFO part. But again, there are significant flaws in that explanation because it doesn't explain how, if it is terrestrial, which it seems to be, but why does it have what appear to be metamaterial or quasi-crystalline structures that appear to be beyond human technology of the 1940s?
Right, and of course, if indeed it is the same sample that was initially sent to Art Bell, we at least know that it was manufactured sometime before 1996. Is it possible that it might not be from 1947?
That's definitely possible, and Jared has pointed out it could be, from them, depends on how solid our chain of custody is, or it could be from 1986 from down the Gorsk, known as the Russian Roswell. So there's possibilities, but that still doesn't change the fact that even in the 80s or 90s, what we see in the material seems to be beyond human technical capability and is at the border, still cutting edge of today's human technical capability, because it's not standard radiation shielding. It doesn't have the standard that you use. So usually for neutron shielding, you use concrete, water, or wax. You don't use this, it doesn't have the right composition to be what's used as standard radiation shielding even today.
Yeah, again, based on the current understanding of the provenance, it is at very least anachronistic.
Yes,
right,
yes.
Which is extremely interesting. Listen, it's officially lunchtime, but I think we're going to continue with a few more questions. I just want everyone to know, of course, technically we're cutting into the lunchtime, and I know some people are probably kind of hungry, but we've got folks lined up. Let's go right over here.
Question on the neutron activation. So have you had any success trying to model with like MCNP or anything like that to get similar performance as what you saw? And specifically, like, if you think it's an interface effect between like the magnesium and the zinc or the bismuth, like, are there interfacial effects, you think? If you tried to start building that stack up, would you see a Gestalt effect, or would it be additive? I mean, have you thought about that or looked at it?
Absolutely, that's on the table. Only reason it hasn't been done yet because no funding, no students, but that's changing. That might be changing. Like I said, with the help of people in this room, I might have time this summer to get to that. And the plan is to use not just MCMP, double check it in Jan 4, triple check it in OpenMC, and try to replicate the behavior of the sample by simulating it. And so my hypothesis right now is that it's a non-linear effect, where there's no magic, there's no new physics, it's novel engineering, where you take these particular elements, isotopes together, and they sort of like maybe bounce the neutrons off of each other and sort of moderate them in a way that's more effective than water, wax, or traditional methods. So absolutely, one of the goals is that by the end of this year is to have replicated in simulation to be able to validate, to say that, to be able to more definitively state that this is some sort of neutron radiation shielding.
Excellent. Dr. Michael Glosson, to the stage, please.
Thanks for a great paper. My question has to do with the first half of it about the sort of inevitability of catastrophic disclosure.
Yes.
Most of the calculations that you do seem to answer the question of, like, at what point does it become inevitable that some smoking gun piece of evidence will make it out into the public, right? But normally what we mean by disclosure is not just that, we also mean that the smoking gun piece of evidence gets out there and everyone believes it. But public credulity is something that we could model, assign some numbers to, and that number seems to be declining, right? So if we take that into consideration and we define disclosure as good evidence getting out there through an authoritative source that's in a position to know and everybody believes, but public credulity is declining over anything, a cell phone video or whatever, how does that skew the line of inevitable catastrophic disclosure?
So it's impossible to know. And that's why on the last page of the paper, I say, look, there are psychological factors that I'm never going to be able to model because it's impossible. And so there's no way of modeling public credulity. Well, there are models, Ben Hanson's been working on this, but there's no perfect, psychology is not physics. So there's no way to know the answer. And so my hope would be that at least you could convince the scientific community, even if you could not convince the public. But yeah, there's no way to know how to dip down the projections I have. And in the conclusion of my paper, I'm very honest and humble about this. I'm like, this could all be wrong because we cannot model psychological and public credulity factors reliably yet.
Excellent. Bob McGuire.
Thank you very much for the talk. I'm especially interested in your neutron activation stuff. Graded Z shielding has been used in satellites for 2 decades, and it's multiple atomic numbers layered in a way that does just that shielding. You should go investigate.
Yeah, I want to check whether it has similar elements. Thank you. So that would be a very plausible, mundane explanation for the sample.
Excellent. I think that's all the questions that we have from here in-house. And so at this time, I'm going to advise we probably take a break, go grab some lunch, and then we will reconvene here because we've got our final panel discussion, which, let me just make sure I've got our time frame all in line right here, if the app will work. Come on now. There we go. Now, we want to be back here at 1 p.m. for our Foundational Approaches to UAP discussion panel. So, I'll see you guys at 1 p.m. Have a nice lunch, and we'll reconvene here as we conclude the 2025 Scientific Coalition for UAP Studies Conference. I'm Micah Hanks.